All right, so picking up where we left off in that last video, we have a 2 on the outside because that is the cubed root of 8. And then, let's see, 6 is going to be left over underneath because there's no perfect cube for 6. Now we have a to the 7th, b to the 3rd. For the variables, I want you to think about how many groups of 3 are in 7, right? Well, think about that is a to the 6th times a. A to the 6th we know is 2 groups of 3. So the cubed root of a to the 6th would be a squared. So that's 2 groups of 3. And then the cubed root of b to the 3rd would just be b because that's 1 group of 3. All right, so we have 2a squared b on the outside, and then what was left over underneath? The 6. And then there's 1a left over, this guy. And that should be our final answer. Yes. 2ab on the cubed root of 6a. Now what I want you to notice here is that the 3 is the index. Sometimes with how the typing is, like people think it's b to the 3rd square root of 6a, but it is the index right here. So just be aware what you're looking at. All right, number 8, the 4th root of 80, a to the 10th, b to the 3rd. So let's take a look. Now we need to talk about the perfect 4th roots, all right? Let's think about it. 1 to the 4th is 1, so 1 is the perfect 4th root. 2 to the 4th is, think about it, 2 times 2 times 2 is 8, times 2 again gets us 16. So 1's a perfect 4th, 16's a perfect 4th. Let's see, 3 to the 4th power. 3 to the 3rd power is 27, times 3 again gets you 81. 4 to the 4th power, we said 4 to the 3rd on the last slide was 64, times 4 again is 256. 5 to the 4th power, 5 to the 3rd power was 125. Times 5 again would get you 625. All right, so do any of these go into 80? 16 does. So we could rewrite this as the 4th root of 16 times the 4th root of 5, because 16 times 5 is 80. And then think about the 4th root of a to the 10th. All right, how many groups of 4 can you make out of 10? All right, let's think about this as a to the 8th and a squared. We know that 8 is 2 groups of 4, and then the a squared would be left over. And then the 4th root of b to the 3rd, how many groups of 4 can you get out of b to the 3rd? You can't get any groups of 4 out of b times b times b. So that'll be left over, this will be left over, and this will be left over. And then this and this we can simplify. The 4th root of 16 is 2. The 4th root of a to the 8th is a squared. And then what's left over underneath? 5, a squared, b to the 3rd. Okay. Let's 2a squared on the 4th root. Oh, I forgot to rewrite my 4th root right here. Of a squared b to the 3rd. Well done. Okay. Let's take a look at number 9. 620 square root of, so we're back to regular square roots. We don't have to think about 4th roots or 3rd roots or anything. Back to regular square roots. Square root of 625, m to the 4th, n to the 11th, p to the 5th. I want you to pause the video, give this one a try, and then unpause when you're ready to go over it. All right, you paused the video, you gave it a try, now you've unpaused and you're ready to go over it. Notice we have this negative out front, so there is going to be a negative here. 625, the largest perfect square, once again, that goes into 675 is 225. So that times the square root of 3. And then we have m to the 4th, n to the 11th, p to the 5th. I'm going to deal with the numbers first, and we'll deal with the variables. Square root of 225 is negative. Well, it's 15, negative out front. So 15 on the square root of 3. Now let me deal with my variables. Square root of m to the 4th, that's a perfect square. So I'm going to have negative 15. Square root of m to the 4th is m squared. Square root of n to the 11th. How many, remember the index here is 2. So how many groups of 2 are there in 11? Well, there's 5 groups of 2 with 1 left over. So there'll be an n left under here. And then square root of p to the 5th. How many groups of 2 are there in 5? Well, there's 2 groups of 2. And there's 1 left over. So it's negative 15 m squared n to the 5th p squared on the square root of 3np. All right, let's see how we did. Negative 15 m squared n to the 5th p squared on the square root of 3np. All right, just a few more. Cubed root of negative 27 x to the 5th. Now, you might be thinking, Miss McGinnis, you can't take the square root of a negative. Well, that's true, but this is not a square root. This is a cubed root, right? So with cubed roots, we can have negatives. So think about this as negative 3 times negative 3 times negative 3. I'm multiplying 3 of the exact same thing together, right? That's 9 times negative 3, which is negative 27. So your cubed roots can be negative. So this is negative 3 x to the 5th. How many groups of 3 are there in x to the 5th? There's 1 group of 3, and there are 2 x's left over. So our final answer, negative 3 x on the cubed root of x squared. Don't forget that guy, cubed root of x squared. All right, number 11. We're just multiplying radicals together. 6 times 12, 72. Square root of 72 x squared. That can be simplified. All right, what's the largest perfect square that goes into 72? I hope you said square root of 36 times square root of 2 is what gives you 72, and then times x squared. All right, square root of 36 is 6. Can't do anything with the 2, so it'll be left under. Square root of x squared is x. 2. And we're good to go. Final answer, 6x on the square root of 2. All right. I want you to try this one on your own. Unpause the video when you're ready to go over it. All right. You ready to go over this? Let's take a look. Multiply our radicands together. That's going to give us 12 times 6, 72. A to the 3rd times A to the 4th, B to the 5th times B squared, B to the 7th. Now we just simplified the square root of 72. It was square root of 36 times square root of 2. And then we've got A to the 4th and B to the 7th. All right, 36, square root of 36 is 6. Can't do anything with square root of 2, so it'll stay under. Square root of A to the 4th is A squared. Square root of B to the 7th. How many groups of 2 are in B to the 7th? There's 3 groups of 2 with 1 left over. So we'll have one of those left over. 6a squared b to the third on the square root of 2b. There we go. We got it. All right, now we're going to distribute a radical. So we've got a radical expression in here, and I'm distributing a radical into these parentheses. Okay, so think about the distributive property. This is 2 on the square root of 6 times 3 on the square root of 2 minus 2 on the square root of 6 times 5 on the square root of 3. All right, so distributing literally means multiplying each of these by the one that's out front. In this case, it's just a radical. So outside number times outside number, this becomes 6 root 12 minus outside times outside, inside times inside, 10 on the square root of 18. Okay? Then each of these can be simplified a little further. So 6, think about 12, is square root of 4 times square root of 3. We know the square root of 4 is 2. So this is 6 times 2 times the square root of 3. So we have 12 on the square root of 3 minus, all right, 10 on the square root of 18. Square root of 18 can be broken down into the square root of 9 times the square root of 2. The square root of 9 is 3, so this is 30 on the square root of 2. Because it did 10 times 3. All right. Now, these cannot be combined any further because the radicands are different. We can only combine our radicals if the radicands are the exact same. So this would be our final answer. Final answer is 12 root 3 minus 30 root 2. All right, I want you to try 13 and 14 on your own. And then unpause the video when you're ready to go over them. My hint for you is take a look at the radicands. Only radicands with the same thing underneath them can be combined. Okay? And then at the bottom, you may have to do some simplifying first. So pause the video, give them a try, and then unpause. All right, you ready to go over these? All right, the like radicands are 5 on the square root of 3 and 2 on the square root of 3. So we just leave the radicands alone, kind of like as if this was 5x minus 2x. It would become 3x, or in this case, 3 on the square root of 3. And then same thing with these guys. Positive square root of 2, or 1 on the square root of 2, plus 4 on the square root of 2 would just be 5 on the square root of 2. And we're good to go. All right, number 14, you did have to do some simplifying first. So square root of 12 is square root of 4 times square root of 3. The square root of 4 is 2. So this is really 4 root 3. All right, plus 18 is 9 times 2. So square root of 9 times square root of 2, that leaves me with 3 root 2. Plus 2 root 3 is simplified all the way. And then square root of 8. 8 is square root of 4 times square root of 2. Square root of 4 is 2, so this is 3 times 2 root 2. So this is 6 root 2. Okay, then we look for like radicands. 4 root 3 and 2 root 3 make 6 root 3. And then